Hello GC candidates, welcome back to School for All. Today I decided to do a little bit of math mechanics, center of gravity. Yeah, because it is one of the challenging topics in math mechanics. So today I want to simplify the thing for you people, hoping that it will really help you in your exam coming. So let us start today's lesson. Center of gravity, or sometimes called center of mass. The same thing, center of mass. Now, when we talk about center of mass, what does it mean to really center of mass? Center of mass is a coordinate. It's okay. It's a coordinate made up of x and y. Exactly. That is giving us the location. That is giving us the location where the mass of a system is what? Mostly concentrated. Is okay. So center of mass is giving us the coordinates in the form of x and y. Let's say x bar and y bar. Where while using those coordinates, I can easily locate where all the mass of a system or of a body is concentrated. So it is denoted as G x bar y bar, where x bar is called x bar is the x centroid and y bar is the y centroid. That is the distance from the center of mass to the y axis. Now, let us talk about discrete masses. It means that if I'm having a system with a discrete number of masses, like let's take an example, I'm having this my y and x bar. I'm having a system like this with a discrete amount of masses m1, m2, m3, m4, and so on. Now, discrete means that what? I can count the number of masses inside the system. They are countable. So I'm having what? A discrete number of masses like this. I want to calculate the center of mass of this system. This is the system. I want to calculate the center of mass of this system. What am I supposed to do? I'm supposed to locate where the masses is mostly concentrated. So I'm supposed to sum. It's okay. I'm supposed to sum all those masses. So this is the definition. The center of mass x bar is given as a sum. Is okay. From I to, let's say the total number of masses n of what? Mi xi divided by the sum of I of what? Mi. This is when I'm having discrete number of masses. I'm giving what? Inside equation, if you are giving a certain number of masses and their respective coordinates. Therefore, to find the x centroid, this is the formula. Mi xi all over sum of mi, sum of the masses. And for the y coordinate, so this one is x bar, y bar. So this is, if I assume that the center of my mass is here, it's okay. So for the y coordinate now, I will take the sum from I to n. N now is the number of masses I'm having. Mi xi, pardon, yi, all over the sum of I. As simple as that. That's it. As simple as that. So let us work a small example to really explain this. Let us work a sample this equation to explain what I'm just doing. For example, okay, I think yeah, a particles of mass is m. So we're having a particle of mass is m kilogram, comma 4 kilogram, comma 3 kilogram, and 1 kilogram. Are in a plane, in the xy plane, at the point with position vectors. We are having the position of each particle. So the position of this one is 5i minus j. The position of this one is 3i plus 2j. The position of this one is negative 3i plus 3j. And the position of the last mass is negative 6i minus 2j. So we are having the different position of the masses. Then we are asked, given that the center of gravity or the center of mass of The center of mass is at the point with position. So we are having the center of mass, position plus. So they are just from giving you vectors. You know that this in vector form, in point form, everybody can do it. So this one represents already our x bar and this one our y bar. Now we are asked to, where a is a constant, find the values of m and n. Find the values of m and n. So by definition, I know that x bar, by definition, I know that x bar is the sum from I to n of mi, xi, all over the sum from I to n of mi. Here our n is simply how many? Our n here is simply 1, 2, 3, 4. It means that my x bar now here will be what? I'm summing. It means that I will take the first mass is m. The x coordinate of the first mass is 5. Plus the second mass is 4. S coordinate is 3. Plus the third mass is 3. S coordinate is -3. And the last mass is 1. S coordinate is -6. Divided by sum all the masses. M plus 4 plus 3 plus 1. 1, 2, 3, 4 masses. And this should give me what? This should give me the x bar, which is A. As simple as that. Nothing to fear there. So I will have here, this implies I will have 5m plus 4 times 3 is 12. But in here will be -9 minus 6 all over 4 plus 3, 3 plus 1, 4, all over m plus 8 should give us A. Okay, student. So I will have here 12 minus 9 minus 6 giving us -3. So this implies 5m minus 3 all over 8 all over m plus 8 takes the value A. Now let me take now y bar. Y bar now will be what? Will be m into -1 plus 4 into 2 plus 3 into 3 plus 1 into -2, all divided by the same mass, m all over 8, because it's the same mass here. Should give us what? Should give us 17 all over 10, because that is y bar, right? So this implies I will have -m plus 4 times 2 is how many? 8 plus 9 minus 2 all over m plus 8 should be equal to 17 all over 10. As easy as that. Okay, now let us take, here I will have 15 minus m all over m plus 8 is the same as 17 all over 10. So I'm having these two equations with two unknowns. So I should go and calculate. I'm having those equations with two unknowns. I should go and find for m and A. Okay, students, so coming out with these two equations, we can now use equation 1 to find for m, since equation 1 is only having one unknown. So from equation 1, we are having 15 minus m all over m plus 8 equals to 17 all over 10. When I will cross multiply, I will have 150 minus 10m equals to 17m plus 17 times 8. Let us multiply. 17 times 8 is 136. Now I'm looking for m. I can bring this one here, bring this one here. I'll have 150 minus 136 equals to 17m plus 10m. So m now will be simply equals to 14 all over 27. So without wasting time, we have the value of m. With that value of m now, we now come in equation 2. We now substitute m by this. We have 5 into 14 all over 27 minus 3 divided by 14 all over 27 plus 8 should give us A. When you finish to simplify, you have 11 all over 2, 30. So that is the value of A. As simple as that, I have the value of A and the value of m. So this is a sample equation under what? under center of mass, where you have been given what the masses with their respective coordinates. Now let us move to the next concept of our lesson. Okay, students, so let us move to the next part of our lesson of today. Now I want now to calculate the center of mass of two-dimensional regular figures, or two-dimensional plane, in fact regular plane figures. Okay, now under two-dimensional plane figure, you see that what I can determine the center of mass, like if a body looks like maybe a rectangle, something like that. If I have maybe a rectangle here, if I want to determine the center of mass of a rectangle of side AB, you see that here is quite easy. I can identify the center of mass directly using what? Geometry, concept of geometry. I know that what? If this is a center, therefore the distance from the center to the side, to one of the sides, or to the longer side is okay, which represent y bar, will be simply equals to a all over 2, and a all over 2, and the distance from here to here, here will be b all over 2, because this is b, and here will be x bar, which is what? X bar is the distance from here to here, will be b all over a all over 2. As simple as that, I have the center of mass of a rectangle, which is a all over 2 and b all over 2. You see that with a rectangle, I can easily identify, using my concept of my knowledge of geometry, I can easily identify the center of mass of a regular rectangle. Now let us go to a square. When you're having now a square of side A, here is also quite easy. A square of side A, we have as a center of mass a all over 2 and a all over 2. As simple as that. Then now, if I consider now a triangle, you see that now for a triangle, it's quite different. If I have a triangle like this, it's okay. The center of mass of the triangle, we reference, if I take in, we reference the base. If I want to calculate the center of mass from the base, or let's say the distance of the centroid, from the base to the center, or from the center to the base, that distance should be 1/3 the height. This is the height. Are you understand what I'm saying? That distance is 1/3 the height. Is okay. But from the center to the top of the, triangle is 2/3 the height. So that is what you should master, please. So the center, it depends on your reference. If your reference is from the center to the bottom or to the base, there your center of mass will be 1/3 the height. So from center to base, but it's from center to the top, therefore it's 2/3 the height of the triangle. I hope you understand it. And therefore for this one is for y. Y is the vertical, and therefore for x is easy. For x here, if this side maybe is let's say c, x bar will be simply equals to c all over c all over 2. As easy as that. Now, if I now have an equilateral triangle, we know that an equilateral triangle is a triangle where all the sides are equal. It means that with an equilateral triangle now, all the sides are like the bases, because all the sides are equal. It means if this is my center, the distance from the center to the base, like this, is okay. So you see that what? The distance from the center to the base is 1/3 the height, 1/3 the height, 1/3 the height. Are you seeing? From the center to the base. Now from the center to the top, look at, if this is 1/3, to complete it should be what? 2/3 the height. From the center to the top, 2/3 the height. From the center to the top, all those vertices are at the top of what? Of our equilateral triangle. So here will be 2/3 the height. So that is the center of mass of an equilateral triangle. It depends on your reference. If you are asked to find the center of mass from the center to the base of the triangle, is 1/3 the height, and you should have the height. Okay, and the height is the distance from here to here, or from here to here, or from here to here. It's an equilateral triangle. All the sides are equal. So from the center now to the top is to take the height. It depends on the reference. So that is it. As simple as that. You have already what the center of mass of regular plane figures. Now it can now happens that you are having, like, we can now combine regular plane figures. If you now combine regular plane figures so that it should form a lamina, you see that to find the center of mass, example, if I'm having a figure like this, you see that some years we are having something like this. These two figures which is being combined. Now I can have another one like this, a trapezium. You see that a trapezium are what? A trapezium is two figures where we combine how many figures? 1, 2, 3 plane figures. Is okay. You see now to find now the center of mass of combined of a lamina of combined what plane figures. You see that you cannot directly identify the center of mass. Yeah. Or sometimes we even remove. Sometimes we can have something like this. You can have a square, then we have a circle inside. We remove this part. You see that this, when we remove it, you're having something like that. It's a figure that you don't know, so you cannot easily determine the center of mass of such figures. From there now, you have a step. You have a step that you should what? You should follow. It's okay. You have a step that you should follow to come up with this. I will show you when we do an example. It's okay, because from there now you should take now what we call the moment about any side of the lamina. Then from there you can identify what? You can identify the centroid. Why am I saying that? Because we all know that what moment is weight times perpendicular distance from the weight from the center of mass to what? To the pivot. Is okay, or to the axis of rotation. It means that what? If I know that what? That distance, maybe the distance from the center of mass maybe is x bar, then I have the weight of the remaining lamina. You see that I can calculate from moment. I can calculate what? X bar using what? Moment. I can calculate so y bar. If I take moment about another side times the weight, should be equal to something. I will show you. I'm only giving you an idea why we should use moment to come out with center of mass, because moment, inside the moment, we see what? We see the center of the mass, because it's the mass which is responsible of turning, moment of turning the lamina. Is okay. Therefore, since that mass is responsible for turning the lamina, if I locate that mass, therefore I will have x bar and y bar. So that is it for plane figures. So I will do an example to better explain what I'm saying here, so don't bother if you're not understanding. Now let us go and calculate the center of mass using what? Calculus. So center of mass using calculating center of mass using what? Calculus. I think when we talk about calculus here, we are talking about integration. Why are we using calculus to find center of mass of a body? This is when we are having a body in the form of a curve, bodies that are very difficult, let's say, to divide into finite portions, so that we can now sum them using sigma and find the center of mass. No, we are using the center of mass. We are applying calculus to find center of mass when you are having curve, continuous bodies. Example: if I'm having, I will take two cases. Here. If I'm having a body like this, I'm having a curve. It's okay. I'm having a curve like this. The curve is denoted by, is bounded by two vertical lines like this, 0. I will call this line maybe or let me put the curve like this so that you should not. If I'm having a curve like this, this x1, x2, this is the curve. Are we understanding? Now the curve is in function of f of x like that. You want to calculate the center of mass of the portion denoted by what? The curve and two vertical lines like this. This is two vertical lines. I want to calculate the center of mass of this portion. You see that the center of mass, I cannot easily say that no, the center of mass is here. No. You cannot. What are you supposed to do here? You're supposed to use integration. Is it okay? You're supposed to use integration. Now, for this first case, we all know that our center of mass is asking us to find x bar and y bar. We agree, right? It means that to find x bar of such a curve is what? X bar here will be the integral, is okay, from x1 to x2 of x, y, dx. Why am I putting the x? Because I'm integrating from x1 to x. So those values are what? Those values correspond to x. Those are what? The boundaries of x. Therefore, I should put the x divided by the integral of x1 also to x2. Yeah, because they are the boundaries of what? Of y dx always. And this is the area under the graph. Sometimes you should know that this is the area under the graph, making x bar to be simply equal to the integral from x1 to x2 xy dx all over the area under the graph. It's okay. Those are the integration application of calculus. There's it. So it is not inside the formula, but please cram it. Please cram it. And look at somebody will say that we are using y here, but we are using y here, but here we are integrating with respect to x. No, but don't even bother, because y is in function of f of x. It means that y can be maybe x squared plus 1, a curve written as x squared plus 1. It means that y is in terms of x. Therefore, when you go and replace here, you have a total integral in terms of x. No problem. Now, it can happen that the boundary now are horizontal, because our boundaries are what? It was delineated by vertical what? Boundaries, vertical lines. Now, in the case I'm now having so you should master the formula as easy as that. The formula is not difficult. You master your formula. Don't say that, oh, I'm praying that you will not come in the exam. No. You are not going in the exam praying or doubting. You are going because you know what will come. You are ready. You are having the what we call the progression sheet. You know all what will come. That in math mechanics, you know always the 8 topics or 9 topics that will come. You know that center of mass will be part of it, and you know that x bar, y bar, application of calculus to calculate center of mass is part of center of mass. So please master all before going in the exam. It can happen that we are having now another graph like this, but the curve is going like this, where the curve is x in function of y, and the curve is bounded by 2 horizontal line, maybe here y1, y2. It can happen that you have this. Now, to find the center of mass of this figure, what are you supposed to do? To find the center of mass of such a figure, what are you supposed to do? You see now, there's a difference here. Here it was bounded by 2 vertical lines, but here now it's bounded by what? 2 horizontal lines. So you come back here, you put, I even forgot. You have an x bar, you have a y bar. You have an x bar. You see that here, our x bar will be simply equals to what? Our x bar here now will be equals to, remember, I even forgot that we find x bar here, right? X bar was the integral from x1 to x2 of what? Of xy dx divided by the area, which was the integral from x1 to x2 of y dx. Now, I forgot to give you y bar. Y bar now, you cram it, you start with half integral from x1 to x2 of what? Of y squared dx divided by what? The area, where the area is it? The area under the graph. Now, look at, for now, our x bar, when the boundaries are y1 and y2, when it is denoted by 2 horizontal lines, you see that here now, I will copy now this one. I will have half. It's like I'm taking y bar here, integral now for y1 to y who? 2 of who? Of x squared who? dy divided by the area now here will be what? The area now will be the integral from y1 to y2 of who? Of x who? dy. Why am I putting x? Because x is in function of who? X is in function of, it means that x maybe will be y squared plus 1. So when you replace it, you have an integral in terms of y. No problem. Then y bar now here will be what? Will be the integral of y1, y2 of what? Of xy dy divided by what? The area. As simple as that. So people should cram it. You see that y bar now here what? Resemble x bar here. Then make sure that the dx now becomes dy. It depends on the configuration of your figure, or the curves, in fact. So that is all about center of mass. That is all what people should know. Simple as that. That's all about center of mass. People should master those formulas. When you're having curves, to find the center of mass, you're supposed to integrate. There's no way you should integrate. So let us now do a sample GC equation to better explain what I'm doing here, so that you should also better understand. Okay, so let us do the first example. In fact, there is example 2, right? At the end, we are having 7 Roman 1. We are having a trapezium ABCD. We are having a trapezium ABCD with uniform density is such that AB equals to 4 meters and BC equals to CD equals to DA equals to 2 meters. Okay, the first thing to do is to try to illustrate the diagram, right? So we'll try to illustrate our diagram here rapidly. It means that what? The side which is different from the other is AB. A trapezium, you know, a trapezium is having one longer side and one shorter one. It means that the longer one should be AB like this, and then there's a shorter one up here like this, where the distance here should be the same. So this is AB. Let's say ABC, D. Yes. So here is 2 meters, 2 meters, 2 meters, but here is 4 meters. Now you see that this trapezium, as I said before, this trapezium should form how many? Should form a trapezium is made up of 3 plane figures. One, which is figure 1, figure 2, figure 3. Figure 1, triangle, triangle. This one, rectangle, rectangle. Now look at, if the distance from here, from D to C is 2, it means that from here to here also is what? From here to here is also 2. It means that from here to here should be 1. And from here to here should be also 1. As easy as that. Now, if I have 2, 1 here, if I want to find the height here, the height will be simply equal to what? From Pythagoras theorem, 2 square will be equal to h square plus 1 square. Pardon? So the height here is simply equal to what? Square root of 4 minus 1, which is square root of 3. I come and put my square root of 3. As simple as that, you come out with your figure. So this is your figure. So you are asked to find, show that the center of mass of the lamina is, so the first question is to ask to show that the center of mass of the lamina, so the lamina here is the trapezium, is 4 root 3 all over 9. So our lamina here is the trapezium. So we all know that what? The trapezium is made up of 1, 2, 3 plane figures. Is okay. It means that our resulting lamina here, we are adding. We are taking this plus this, because sometimes we subtract. Sometimes we say that find the remaining lamina when this part is removed. So, but here we are now adding, because to form a trapezium, we should add this, this, and this. Now, follow this step. Follow it exactly as I'm doing here. When you're in the exam hall, I think you're having already how there are many ways to solve it, but the best way is to put inside what? A table. Is okay. So follow what I'm doing here exactly. When you have already your figure, are we together? When you have your figure like this, you want to come out with the center of mass of the lamina which is the resulting figure. When you are adding the different, or when you are subtracting, here we are adding 1, 2, 3 to form the lamina. You come out with your table. I said that follow exactly what I'm doing here. Your table should have a column of portions. The table is to summarize it, making more easier. Portion. We should have a column for weights. Weight. Now, sometimes others call it mass. No problem. Weight, mass is the same thing. It's okay. Whether weight is mass times gravity, and gravity here is a constant. We cancel all through. So it's the same thing. And here now is the distance from the centroid. Distance of AB to the centroid, and then here is distance from, well, the side is AB, so distance from AB. So there is it. The first portion here, I'll put here figure I, figure double I, figure 2, and figure triple I, figure 3. Then at the end, I'll put my lamina. Okay. When you have your table, the next step, you should come and calculate the weight. It's okay. Now, to calculate the weight, don't go and put mass, gravity. No. It's okay. The first thing you should know is that weight is proportional to what? Area. It means that what? The bigger the area of this thing, the bigger the weight. We all agree. And if weight is proportional to area, it means that weight can be written as a certain lambda area. So lambda here is the weight So sometimes we call lambda the density, that is the weight per unit area of my figure. And it is uniform, so it is the same for any figure that make up our lamina. Now, lambda is W, which is the weight, is lambda A. It means that for the first figure, W for the first figure, this you are doing on your rough paper. Then you come and fill it here inside your answer sheet. So Wi now here, W of our first figure will be lambda times the area of the first figure. The area of the first figure, we know the area of a triangle is half base times height. The base, as you can see here, the base here is 1. The height is root 3. So I will have root 3 all over 2, as easy as that. So I'll come here now. The weight will be simply root 3 all over 2 lambda. I hope it's making sense. Okay. Now, it means that for figure 2 now, I'm having now a rectangle. The rectangle, area of a rectangle is A, side times length times width. Let's say the length is root 3, the width is 2. So I'll have 2 root 3 without forgetting my lambda because it's the width. Then figure 3 now is still half base times height. So it will still be root 3 all over 2 lambda. So that is all about the weight. As simple as that. Now for the distance from AB to the center of mass, you see that for this thing, if I start with the triangle, if I start with the triangle, the distance from the center to the base, because the base is side AB, this is it here, this is side AB, so it is the base. The distance from the center to the base, I told you that what is 1/3 the height. Center to base, 1/3 the height, remember. So I will come here, I will put directly my 1/3, and the height, this is the height of the triangle, which is root 3. I do same here. For figure 2 here, the distance from the center to side AB is what? From here to here, look at, from here to here is root 3. So that from here to here will be root 3 all over 2. And then for figure 3, the distance from the center to the base, always center to base, 1/3 the height. Is not, if it was like this, let's say if they were asking for the distance from the center to the side DC, DC is from here up to here. You see that is from the center to the top. It's not the base here again. Center to top. You see that one will be 2/3. But since the base here, AB is the base, so center to base of the triangle, it should be what? 1/3 the height, which is root 3. That is all. Please, students, you should be able to come out with this. That's already a mark. That is already a mark. So when you are able to come out with the distance from the side AB to the center, the weight, you cannot fail the question. You cannot. Now the lamina now, the area of a lamina is what? A trapezium. Area of trapezium is half the longer side plus shorter side times the height. You see that it is half, but not 1/3. Half longer side is 4, shorter side is 2, the height is root 3. 4 plus 2, how many? 6. 6 divided by 2, 3. 3 root 3. You see that this is the area of the lamina. You see that if you do, like I told you that the lamina here is trapezium. Trapezium means we are adding all those 3 planes figures. If you take this plus this plus this, it will give you the same to look at. Root 3 all over 2. I will remove the lambda. I'm looking for the area. Root 3 all over 2 plus 2 root 3 plus root 3 all over 2. This 2 is giving already half, same denominator, half 2. I will add, give already root 3 plus 2 root 3, which is 3 root 3, as easy as that. Yeah. Okay. Then, don't forget I should put lambda here because it's a weight. Then the distance from the center to side AB, yeah, we don't know that distance. It's a vertical distance, therefore it is y bar. That is the distance I don't know. It's what I'm looking for. Okay, as I told you, to look for this y, you take moment. The only way to look for that y is to take moment about what? About side AB. So I will take the moment about side AB so that it should turn like this. While turning, another moment is the weight force times the perpendicular distance. So the force of the lamina, or let's say the weight of the lamina, is 3 root 3 lambda. the perpendicular distance from the center of mass of the lamina to AB, we see that what is y. Are you seeing how the y is coming out? It's from there now that we'll calculate it. So from the moment y will come out, y bar will come out, we calculate it. Then I will now take the weight of all the lamina is this should be equal to what? The moment of each figure of our lamina about the site AB. Is it now? It's making sense because the weight of the lamina is the sum of those masses. Okay, the sum of those weights of different plane figures. So here now I will have root. Okay. Here I will have root 3 all over 2 lambda times 1/3 root 3 plus 2 root 3 lambda times root 3 all over 2 plus root 3 all over 2 lambda times root 3 all over 3. So that is it. Then from there, I should now simplify. You can see that what? Root 3 lambda cancel here, root 3 lambda cancel here, root 3 lambda cancel here, root 3 lambda cancel here. I will stay with 3 y bar equals to root 3 all over 2 times 3 is 6 plus 2 root 3. No, this 2 here cancel with this, so plus root 3 plus simply root 3. Then plus this one, root 3 all over 6. Now, I bring these two together since they have the same denominator. When I will bring them, I will have this plus this is 2 times that. So 2 divided, I will have 2 divided by that. I will have root 3 all over 3 plus root 3 y bar. So my y bar now will be equal to what? LCM here. You see that here is the same as 1 all over 3 plus 3 all over 3. So it is 4 all over 3. So I will have 4 root 3 all over 3. So therefore my y bar will be equal to, I make y bar the subject, I will multiply, I will come and divide here, I will have 4 root 3 all over 9. That is the proof. As easy as that. So student, what is difficult here? Nothing difficult, so nothing to fear, students. So that is it. And it is the same for all questions. It's the same. You come out with your table, you take the moment about one of the sides to find y bar. Now here they were not asking for x bar. So if they were asking for x bar, I will take now moment about a vertical side. So since it's not precise, let us only find what they asked us to find. So now let us go to the next question. Okay, student. So the next question is asking us, okay, the lamina is freely suspended from D and hangs in equilibrium. B, find the angle between DC and the vertical through D. Okay, it means that now the lamina is, let's say the lamina is now fixed at one side, D. And for it to be in equilibrium at D, it means that the center of mass should be exactly below it. It's okay. And when the center of mass is here, remember that our lamina was something like that. So we don't know where the center of mass was. Let's say if I estimate that the center of mass was somewhere here of the lamina, I'm estimating, was somewhere here of the height, because remember that the y bar was 4 root 3 all over 9. So 4 root 3 over 9 should be somewhere near what? Near AB. It's okay, because here the distance here was root 3. So let us say the center of mass is like this. Now if I fix it here now, you see that this one will turn. I fix a point here like this, it will turn like this, then come into equilibrium. And it will come into equilibrium. At the moment of equilibrium, G is exactly below D. G is exactly below D. Now making our side DC now to form a certain angle here with the vertical theta. So that is what they are asking for. And you see that now will form what? It will now form a right angle triangle. Where this distance, the horizontal distance from G here will be x bar, which is simply equals to what? Look at, if D is 2, the distance from here to the horizontal distance is simply equals to 1, because here is 2. So when I will separate this, I will see that it's 1. Okay, here is 1, so I will put here 1. Now the distance, this other side, now people should look up. This other side now, to get it, we know that the height from here to here is root 3. That is the height. From the center of mass to the base AB is 4 root 3 all over 9. It means that if I want now from the center of mass to the top, I should take root 3 minus 4 root 3 all over 9. So to calculate this side, I will take now from the center of mass to the top now. I'm taking now from the center of mass to the top, not from the center of mass to the base again, no. Center of mass to the base, 4 root 3 over 9. Center of mass to the top, I should take down the height of the trapezium, which is root 3 minus that. You see now from here, theta is simply equals to tan inverse. Because I'm having adjacent and opposite, so I will take tan inverse of what? Tan inverse, you know that what? Tan theta is opposite all over to an opposite all over adjacent. So it will be tan inverse of opposite here is what? 1. Adjacent here is what? Root 3 minus 4 root 3 all over 9. So that is the angle. Then you can now simplify. So theta is equal to tan inverse of 9 here, 9 all over, is it now? 9 minus 4, 5. 9 minus 4 is 5 root 3. So there is the answer. As simple as that. You have the angle formed between DC and the vertical passing through D. So there is it. So there is nothing difficult there. Here is 9. This 9 will go up. Now, let us go to Roman 2 of the question. Given that the shaded area in the figure below is bounded by two curves given by, so we are having two curves like this. It's bounded by two curves and it is delineated like this. Here is 0. Here the distance from here to here, you are seeing that is A, means that here is A. Okay, the first curve is a curve y equals to x squared all over A, and this one is a y equals to, here is the curve x equals to y squared all over A. Voilà. So that is it. We are asked to find the center of mass of the curve, of the shaded portion of our curve. Now, you people should, okay students, so you people should try and see how can we do it. It's okay. We already know the formula of center of mass for curve diagrams. Now, but here we are having, first of all, we are having two curves that delineate what? An area. So I should first of all come out with the equation or the resulting equation for this portion. Is okay. I should come out with the resulting equation for this portion. And in mathematics, when you are having two curves, we want to find maybe the area under two curves. First of all, come out with the equation representing the what? The bounded area. And that equation should take the bigger curve. I will call that bigger curve y1 minus the smaller curve y2. So that is the curve. Is okay. That is a curve which is being delineated by y1 and y2. Okay, or bounded by y1 and y2. Now you can let maybe now, because the bigger curve, the one which is on top, when I say bigger, it means that the one which is on top of the other one should be y1, below should be y2. Now look up, I'm having here x equals to y squared all over A. Now it depends on you. If you want to represent it, like here I took y, it means I should represent all my curve in terms of, x, padding. So I should make y the subject, like here it's already okay. It's okay. So here already is my y2. Then here I should make y the subject. I will have y1 will be equals to what? Be equals to ax, square root of ax. So that is my y1. I will understand what I'm saying. First of all, do y the subject here before naming your y1, y2. That is it. So here it means that my y is simply equals to root ax minus y2, which is what? X squared all over A. So that is what this is the equation of the curve. This is the equation of the curve representing what? The bounded portion. This is it. Now, when I have now that equation, it means that I will use the formula where I'm having y in function of x. So that formula was the first one that we did. It means that my x bar here, they are looking for what? X bar or y bar. Let me verify. Okay, yeah, S bar. My S bar here will be, look at the integral. It means I will take which boundary. I will take the vertical one. Is okay, since my y is in terms of f of x, I will take this vertical one from 0 to a. The integral from x1 to x2 of what? Xyd dx divided by the area, which is the integral from x1 to x2 of what? Yd dx. As simple as that. So I will first of all come and find, for this one will be the integral from 0 to a. Yeah, the limits are from 0 to a, because the distance from here to here they denoted as a, so here is a. Of who? Of x in bracket. My y is this one, square root of a x to the power half, same thing, minus x squared all over a d who? D dx. Then I integrate, as easy as that. When I will integrate, when I will multiply, first of all, this one I will have let me put integral from 0 to a root a x to the power what? When you have x times x half, x to the power 1 times x to the power half is the same as x to the power 1 plus half, which is the same as x to the power 3 all over 2. So I'll have 3 all over 2 here, minus, I will multiply there, I will have x cubed all over a d dx. Don't forget to put your bracket. When I will now integrate, I will come out with root a x to the power. Now I should add the power here by 1. I will have 5 all over 2 divided by 5 all over 2 minus x to the power 4 all over 4a from 0 to a. I'm integrating. I think people know how to integrate. When I replace now, I will have root a. Root a is the same as a to the power half times a to the power 5 all over 2 divided by 5 all over 2 minus a to the power 4 all over 4a. The other one will give 0. No need to put it again. So the 2 will go up. Now a to the half plus 5 all over 2, loss of indices, a to the power half times a to the power 5 all over 2. I will add the powers. I will have 6 all over 2. 6 all over 2 is how many? 3. So I will simply have here 2 a to the power 3 all over 5. These 2 will go up. Minus a cancel one time, minus a all over how many? 3 divided by 4. When I do the LCM here, LCM here is 20. 20 divided by 5. 20 divided by 5 is 4. 4 times 4. 4 times 2, 8. 8. 20 divided by 4. So here I will have 8 a squared minus 20 divided by 4 is 5 minus 5 a squared, making the answer to be 8 minus 5 is how many? 3 a squared all over 20. So I will come here directly. I will note it here directly so that we should not forget. It means that the first integral I calculated is simply equal to 3a squared all over 20. Now let us go and calculate the area. Let us go and calculate the area. We all know that what the area now will be the integral from 0 to a of what? A to the power half x to the power half minus x squared all over 2 then d dx. Now I will integrate directly. I will have a to the power half x to the power how many? Half plus 1 is 3 all over 2 divided by 3 all over 2 minus x cubed all over how many? Here is a, pardon. S cubed all over a in bracket times 3 from 0 to a. Now when I replace the boundary, I have a to the power half times a to the power 3 all over 2 divided by 3 all over 2 minus a cubed all over 3 a. No need to put 0, you will cancel it all through. So that part we leave it. Now here, 2 will go up. When I have half plus 1/3, a to the power half times a to the power 3 all over 2, I should add the powers. So here I will have same denominator. I'll have 4 all over 2, which is simply a squared. Then this 2 all over 3 plus like that. Then minus a cancel here one time. I will have a squared all over 3. Same denominator. I subtract. I will have a squared all over 3. As simple as that. Then with these values, I now come and calculate my x bar, which is simply equal to what? 3a squared all over 20 divided by, so it's the same as times 3 all over a square. Pardon, here was a cube. If I remember, here was a cube, pardon. So here should be cube. Okay. So here you will see that what? You see that when I will multiply, you can't say I'll have 1 time. So my x bar is simply equals to 9a all over 20. As easy as that. That is the proof. 9a all over 20. So that is the proof. You see that nothing is difficult there, students. So you people should concentrate. Only concentrate. I hope that the lesson of today will really help you. So see you later for another amazing video.